Okay, so I'm going to explain squeeze theorem, which is also known as sandwich theorem. This theorem tells me that if I have three functions such that g of x is greater than or equal to z of x, and at the same time g of x is less than or equal to f of x, then the limit of z of x at any point, if it is equal to the limit of f of x at that point, let's say their value z is L, then the limit of the middle function, which is g of x, it will also be equal to L. Okay, so I'll try to show it to you on the graph here. Let's say the z of x, this is a function here, okay, represented by this line, and let's say we have g of x, okay, and lastly we have f of x. Let's say this function is represented in such a way, okay. So this is z of x. Let's say here we have g of x, which is in the middle, and we have f of x here, okay. So now imagine z of x and f of x, their value, which is the y value, they are same at any point, right? Let's say I can just name it where are they together? They're almost same when we reach this point, right? So let's say a. So let's say when x approaches towards a, the limit of z of x is equal to the limit of f of x, okay? But we already know if they both are together same, right? If the limit of z of x is equal to the limit of f of x, so how about the limit of g of x, which lies between them? So it's very simple and it's very easy to understand that the limit of g of x, which lies between those two, it will also be equal to the value of, let's say this is L, right? So this will also be equal to L. So if the limit of z of x is equal to the limit of f of x at any point, then the limit of g of x as x approaches to that point, let's say the point is a, it will also be equal to L. And where can we use it? We use it to find the limit of functions which cannot be found directly. For example, here, if I want to find the limit of x squared sine 1 over x, when x approaches to 0, then let's say I try to put the value directly. Let's say x equals 0. So if I put 0, this will be sine of infinity, which cannot be found, right? So what I need to use the squeeze theorem to solve it. And how am I going to do it? Well, there is one thing I already know about sine of any value, right? What I know about sine of any value is the sine value cannot be less than -1. It can be equal to -1, but it cannot be less than -1. And on the other side, I know that it cannot be more than 1. Okay? Now, what can I do? If I multiply 3 of them with a positive number, so the equality sign, they will still be same, right? They will not change. So let's say I want to multiply each one of them with x squared, right? So this will give me minus x squared, okay, and here it will give me x squared sine x squared. Okay, now let's apply the limits, okay, the limits that we want to find. Now apply the limit on each one of them, right? Minus x squared when x approaches 0. Okay, limit of x squared sine 1 over x when x approaches 0. Limit of x squared when x approaches 0. Now, using the squeeze theorem, if I find the limit of this and find the limit of this, and I saw that the limit of them at this point is same, then I can use the same limit for the function in the middle. because I just saw that I cannot find it directly, so I will use the indirect way to get the limit of the middle function, right? Now, if I put x equals 0, right, in this function, this is going to be what? This is going to be minus 0 squared, right? So how much is it? This will be equal to 0. How about here? This will be also equal to 0. If I replace x squared with 0, this will also give me 0. So the limit of this function is 0. The limit of this function is 0. So how about the limit of this function? Okay, this will also be equal to 0.